You had a stomach thing last week. Tell me about it. Actually, don't because I already know. Something at a restaurant sat wrong, or maybe it was that gas station sushi you told yourself was probably fine, and then 4 hours later you were lying on the bathroom tile doing your best impression of a dying Victorian child. And the drama of it, the texts to people, the canceling of plans, the solemn vow to eat better from now on, which lasted approximately 48 hours until the pizza cravings kicked back in. I'm not judging you. I've been there. We've all been there. Modern food poisoning is genuinely miserable, but I want you to hold that miserable memory in your head very carefully, because I'm about to do something to it. It's roughly 27,000 years ago, Northern Europe. The last glacial maximum is deepening, which is the scientific way of saying that the planet has decided to become almost completely uninhabitable. Average temperatures across the continent have dropped somewhere between 8 and 15 degrees Celsius below where they sit today. That's not a cold snap. That's not a rough winter. That is a geological event happening in geological time, but being experienced in human lifetimes, in human bodies. Right now, this generation, this winter. The megafauna that this group has been hunting, woolly mammoths, giant deer, bison, have either migrated into territories that require weeks of travel to reach, or they are simply gone. The landscape is a tundra steppe that makes the Siberian interior look welcoming. The vegetation is mostly frozen. The rivers are locked under ice. And inside this specific group of people, maybe 30 to 40 individuals, the combined caloric reserve sitting in every stomach at this exact moment is running critically low. Not, we should probably find something soon, low. Children are starting to show the early signs of protein-calorie malnutrition, low. And your gas station sushi is sitting there in your memory, getting smaller and smaller, until it disappears entirely. This is the moment I want to talk about. Not the heroism of it, not the mythology. The pure, clinical, almost terrifying problem-solving that happened when the human body, your exact body, the same wet machine you're using right now, was pushed into nutritional zero. Because what these people did when the food ran out was not what you'd expect. It wasn't desperate, random, hopeless scavenging. It was chemistry. It was engineering. It was a level of practical biochemical intelligence that, if you told a nutritional scientist about it without explaining the context, they would assume you were describing a laboratory process. Let's start with the thing that nobody talks about when they romanticize Paleolithic diets. Most of the plant-based food available during a glacial winter in Europe and Central Asia was trying to kill you. Not metaphorically, chemically. Literally, biologically, actively trying to kill you through defensive molecular compounds that evolved specifically to stop mammals from eating them. Take the wild tubers and roots that were available under the snow. Certain species in the genus Solanum, ancestors of the modern potato, contain glycoalkaloids, specifically solanine and chaconine. These compounds cause cell membrane disruption, acetylcholinesterase inhibition, and at sufficient doses they can trigger cardiac arrhythmia. Wild tubers can contain glycoalkaloid concentrations 20 to 50 times higher than what modern food safety standards allow in cultivated potatoes. Eating them raw in the quantities required to sustain a calorie deficit would not have given you a stomachache. It would have put you on the ground. The ancestral solution to this was one of the most quietly astonishing things in all of human prehistory. They ate clay. Not accidentally. Not in a they were so desperate they resorted to eating dirt kind of way. Intentionally, deliberately, systematically. This practice is called geophagy, the deliberate consumption of earth, and it has been documented in hundreds of human populations across 6 continents. But the mechanism was not understood by Western science until the mid-20th century, when researchers began analyzing what specific types of clay were being consumed and why. The answer is kaolinite. Kaolin clay is a fine-grained silicate mineral with a platelet structure that gives it an enormous effective surface area per gram. When it passes through the gastrointestinal tract, it functions as a chemical binding agent. It adsorbs glycoalkaloids and other plant toxins, essentially trapping them against its surface before they can be absorbed into the bloodstream. Lab studies conducted at Cornell University and published in journals of comparative physiology have confirmed this mechanism. Kaolinite measurably reduces the absorption of solanine and similar compounds in primate digestive systems. The effect is not marginal, it is substantial. So what these people were doing, what looked from the outside like desperation, like poverty, like something pitiable, was actually the precise and knowledgeable preparation of a detoxification agent. They knew from accumulated generations of observational knowledge that if you eat this root with that specific pale clay from that specific deposit near the stream, you won't die. They couldn't have told you the molecular mechanism. They didn't need to. The knowledge was there, encoded in behavior, passed through instruction, kept alive through exactly the same process that keeps any other critical technology alive. Someone taught someone who taught someone else, who is now in the middle of a glacial winter with 30 hungry people depending on them, mixing a fistful of pale clay into water before the meal, and they did not die. Now I need you to stay with me here, because this is where the story takes a turn that genuinely made me pause the first time I understood it fully. The clay detox worked. The group survived the root and clay phase of the winter. But surviving on detoxified wild tubers doesn't get you through a full Pleistocene winter. The caloric math doesn't work. Wild roots are carbohydrates, useful but not enough. The body running in extreme cold, doing the physical work of survival, burns through calories at a rate that would horrify modern fitness trackers. Researchers studying Inuit and other Arctic-adapted hunter-gatherer populations have documented caloric expenditure during winter survival conditions of 5,000 to 6,000 kilocalories per day. You need fat. Dense, concentrated, metabolically potent fat. The kind that might be sealed inside the bones of an animal that died 3 months ago. Here is a biological fact about bone marrow that took me completely by surprise when I first encountered it. Marrow is approximately 90 to 97% fat. It is one of the most calorie-dense substances a human body can eat, roughly 3 times the caloric density of muscle protein. And here is the remarkable part. The bones of large mammals function as a near-perfect hermetic seal for marrow. The dense cortical bone around a femur or tibia acts as a biological container, protecting the marrow inside from the bacterial decomposition that destroys every other part of the carcass within days. A study published by researchers at Tel Aviv University, examining remains from Qesem Cave in Israel, dated to roughly 420,000 years ago, found evidence that early humans at this site were deliberately leaving leg bones with the skin still on for up to 9 weeks before consuming the marrow inside. 9 weeks. Intentional food storage, using the animal's own biology as a refrigerator, which means that when this group, 27,000 years ago in a frozen European winter, came across the remains of a megafauna carcass, something large that had died earlier in the season, stripped by wolves and hyenas down to bones and sinew, they did not walk past it. They recognized it for exactly what it was: a sealed vault. The leg bones of a woolly mammoth or giant deer contain marrow that can remain nutritionally intact for weeks or months in frozen conditions. Getting to it required specific stone tools, hammerstones capable of delivering the right kind of impact at the right angle to crack the cortical bone without destroying the contents. The archaeological record from sites across Europe and the Levant shows these impact patterns so consistently, so systematically across different populations and time periods that we know this wasn't improvisation. This was a practiced skill. You cracked the bone at a precise angle along the shaft, extracted the marrow, which in a large animal bone could represent hundreds of calories in a single extraction. And you ate it directly, or rendered it into a fat source that could be stored and consumed over days. Think about the knowledge stack required for that. You need to know which bones from which animals preserve marrow longest. You need to know which stone tool geometry produces the right impact without shattering everything. You need to know which dead animals are worth the energy expenditure of trekking to, and which have been compromised. And you need to know when a carcass that looks ruined is actually still holding viable calories inside its skeleton, locked away from every other predator in the landscape, except the one that figured out how to use a rock as a key. That's not survival instinct. That's expertise. That's accumulated, multi-generational, transferable, technical knowledge operating in exactly the same cognitive register as any other specialized human skill. The third piece of this, the one that I think is the most quietly mind-bending, involves acorns. Specifically, what you have to do to an acorn before it becomes food. Acorns from oak trees contain tannins, tannic acid to be more specific. Concentrated tannins are astringent at low doses, deeply unpleasant at moderate doses, and hepatotoxic, liver damaging, at the quantities you'd need to consume to sustain yourself on acorns alone. Raw acorns taste terrible, specifically because of this. The bitterness is the toxin advertising itself. Raw acorns are not food in any meaningful caloric sense for a body in survival mode. They are a botanical trap. The solution required patience that is almost impossible to relate to a culture that gets anxious when a web page takes more than 2 seconds to load. The process is called leaching. You take dried acorns, crack them, grind the nut meat into a rough flour, and then expose that flour to sustained water flow, in stream-fed natural basins, in woven baskets suspended in running water, in sand filters through which water is channeled repeatedly. The tannins are water-soluble. They dissolve out slowly, over hours, over days, over weeks if necessary, depending on the tannin load. Archaeological evidence for this process has been found across Europe, North America, and East Asia. Groundstone processing tools with acorn starch residue, leaching basins carved into bedrock near watercourses, storage pits lined with plant material to prevent recontamination. The sunken village site in Oregon has yielded over 100 hemlock-lined leaching pits. The Shangshan site in China shows evidence of starch processing consistent with prolonged water treatment going back to the early Holocene. But the version of this I find most extraordinary is the combined technique, geophagy plus leaching, where clay was added directly to the acorn processing to chemically bind the remaining tannins while the water carried off the bulk. 2 independent detoxification mechanisms running simultaneously on the same batch of food. Not because someone read a paper on it, because someone figured it out and then taught it, and then it worked, and so it kept being taught. The caloric yield from properly leached acorn flour is significant, around 500 calories per 100 grams of dry flour with a reasonable macronutrient spread. Not as dense as marrow, but stable, storable, cookable, and derivable from a food source that literally falls out of trees in autumn in sufficient quantities to feed a group through multiple months of winter. If you know what you're doing to it. If you know what you're doing, that phrase keeps coming back. Because what we are actually talking about here, underneath all the specific details about kaolinite and tannin lixiviation and cortical bone fracture patterns, is knowledge management as a survival technology. The difference between the groups that made it through the last glacial maximum and the groups that didn't was not primarily physical. It was not strength or speed or how many calories their bodies burned at rest. It was whether they had accumulated and maintained and successfully transmitted the specific procedural knowledge required to turn toxic, inedible, biologically hostile raw materials into food. The people who didn't know about the clay with the roots died. The people who hadn't learned which bones held viable marrow and how to open them walked past calories sealed in plain sight. The people who lost the leaching sequence or couldn't source the right clay deposit lost access to entire categories of nutrition that their environment technically contained. Knowledge. Not muscle, not teeth, not even fire exactly, though fire helped with all of it. The survival edge of a Paleolithic winter wasn't who was toughest, it was who had the best curriculum. I find that weirdly comforting and weirdly disturbing in equal measure, because it means these people weren't operating on raw instinct in a fog of desperate survival. They were operating on the accumulated intellectual output of dozens of generations of dead humans who had already solved these problems, paid for those solutions with their lives, and embedded the answers in the only storage medium available, the memories and behaviors of the people still breathing. There are researchers who study this, specifically the transmission and maintenance of complex technical knowledge in small-scale, pre-literate societies. And what they've found consistently is that this kind of knowledge is extraordinarily fragile under certain conditions. A population crash, an epidemic that takes out the oldest generation, the knowledge holders, in a single season. An extended drought that forces migration away from the specific environment where the knowledge is applicable. Any of these events can sever the chain. And once it's severed, it doesn't spontaneously reassemble. The group that loses the leaching sequence doesn't rediscover it from scratch in a single generation. They go through the acorns sick, or they don't go through them at all. This is the thing that I cannot stop thinking about when I look at the survival data from the last glacial maximum. Roughly 26,500 to 19,000 years ago. Population estimates for Europe during this period, derived from genetic analysis and site density modeling, suggest that the total human population of the entire continent may have dropped to a few thousand individuals clustered in isolated refugia. Small, relatively warmer pockets in what is now southern France, Iberia, and parts of the Italian peninsula and the Balkans. The rest of Europe was largely abandoned. Not by choice. By the failure of the knowledge transmission chain under conditions extreme enough to break it. The people who made it into the refugia were not just physically resilient, they were the ones who still knew how to feed themselves on what the frozen world offered, who still knew about the clay and the roots, about the bones and the hammer, about the acorns and the water, and the weeks of patience required to turn poison into calories. And they held that knowledge in their bodies, in their practices, in their stories, in the routines they maintained, even when the cold was so severe, and the group so reduced, and the social fabric so threadbare that maintaining any routine at all was an act of will that most modern people can barely conceptualize. They were eating poison on purpose and surviving it. They were cracking open bones that had been lying on frozen ground for months and finding fat inside them worth traveling for. They were spending 3 weeks turning a handful of acorn flour into something edible with nothing but water and time. And doing all of this while managing the social coherence of a small group under existential stress, in the dark, in temperatures that required constant fire management just to not die overnight. I genuinely do not know what to do with that level of capability. I don't have a framework for it that fits neatly into any category I normally use. It's not primitive. It's not instinctual. It's not simple. It is the full expression of human intelligence applied to the hardest version of the hardest problem, without any of the infrastructure we've spent 10,000 years building to make that problem easier. The last glacial maximum ended gradually around 19,000 years ago. The ice retreated. The megafauna began to return. And then, fairly quickly on geological timescales, to vanish as human hunters expanded back across a warming continent, with all that accumulated knowledge intact and a new range of landscape to apply it to. Agriculture came later. Writing came later. Cities came later. The Industrial Revolution, the invention of synthetic fertilizers, the global food supply chain, the gas station sushi, all of that is a single, very thin layer sitting on top of something much older and much more expensive than anything we normally think to think. 30,000 years before the first grain was domesticated, someone was mixing pale river clay into wild potato mash so their children would not go into cardiac arrest before spring. That's where we're actually from. You're watching this, presumably somewhere climate-controlled, with food available to you in quantities that would have seemed supernatural to any human alive during the events I just described. A smartphone in your hand. Clean water from a tap. Options. So many options that the mental load of choosing between them is considered a legitimate source of modern anxiety. And that's not ironic. That's the whole point. That's the inheritance. That's what all of that knowledge, all of those cold winters, all of those people eating clay and cracking bones and leaching acorn flour and frozen streams actually built eventually across every generation between them and you. If this landed differently than you expected, if the clay and the bones and the tannin leaching changed something in how you understand where you actually came from, subscribe. Leave a like. Hit the notification bell. Because we're not done going back. The further we go, the stranger and more extraordinary it gets. And honestly, the least these people deserve is for someone to pay attention.